All right, so you are welcome back. I have to apologize that the Wi-Fi went off. For whatever reason, I think the power went down because I'm sitting outside my office to try to have some certain level of silence. So now I want us to quickly go through the first part. Which I believe by now you know what you ought to do about this part. Now, the part here has to do, the first part here has to do with measurement of heat. So, and I want us to define, to dwell on the definition of heat and temperature. And after that, I am going to look at what we mean by temperature scales. And after that, we will look at a few calculations, and that will bring us to the end of this discussion today. Okay, so this is the first part, Unit 1. And your Unit 1 has to do with the concept of temperature and heat. So let me begin open a discussion on this. The question that I would love to ask any one of us here is this: what do you understand by temperature? How would you define temperature? How do you define temperature? Let me see if I can get, let me unmute you so that you can discuss that. How do you define temperature?
Can I speak, sir?
Can I answer that, sir?
Yes.
Temperature is the degree of hotness.
No, one person now. Let me, one person at a time. The lady first.
Okay, temperature is defined as the degree of hotness or coldness of a body.
Degree of hotness or coldness of a body. Okay. All right. Any other suggestion than that one? Any other definition?
Yes, sir.
Yes.
Degree or intensity of heat present in a substance or object.
Intensity of what?
Temperature
Intensity of heat
present in or object.
All right. Okay. Okay. We will discuss that. Okay. All right. Is there any other definition than this?
Yeah, can I say something, sir?
Yes.
Temperature is a physical quantity that expresses quantitatively the perceptions of hotness and coldness of an object.
We are saying it is
Is
quantitative.
a physical quantity that expresses quantitatively the perceptions of hotness and coldness of an object or body.
Okay, physical quantity. All right. Okay, so let us end with that. Okay, let me end with that. But let me ask from the definitions you have given. From the definitions you have given so far, okay, let us attempt to define, to see whether you understand what you are talking about. Now, if the other person said degree of hotness, so what do we mean by degree now? What do we mean by degree? You see, now when you say degree, there has to be a way of you quantifying it. The last speaker talked about a physical quantity. So if I may ask further, what do we mean by a physical quantity, by the way?
So physical quantity means the increase and decrease.
No, that's not the meaning of a physical quantity. What is a physical quantity? What do we mean by the word quantity? Is there anybody? Anybody?
Amount of something.
Amount.
Yes.
Okay. Yeah. All right. Now let me save some time. You see, in everyday discussion, we have heard the word temperature. Okay. We've heard the word heat. Now, if I ask us to define some of these things, like some of you attempted, you notice that our definitions may not be quite precise. So the last person that spoke used a term that is much more appealing. That's a bit much more scientific. That is quantity. So now I asked, what do we mean by a quantity? A physical quantity. What does it mean? Now, every observation that we make in nature, we have to have a way of describing what we have observed. Okay? Now, somebody said degree of hotness or coldness of the body. Okay? But that does not give us a way of measuring. It doesn't give us a way of measuring how hot or how cold a body is. Okay? So that kind of definition is subjective. Let me give you a typical example. All right? Now, put a hot water. All right? A hot water and a warm water. Warm water, that is, take the hot water and mix one and lower the temperature a bit and put them in two bowls. Now put your right hand on the warm water and your left hand on the hot water. Okay, you notice that in your left hand, you feel hotter. Okay, you feel the heat there much more, isn't it? It's hotter, while this one feels cooler. But now, if you transfer your left hand and put it in the bowl where you have this warm water, you notice that you feel cooler. All right, it feels cooler on your left hand now when you are in this other bowl, while this one still remains warm. You feel as warm as it has been. So what does that tell us? It tells us that the measurement of temperature based on our senses of perception is not precise, is relative. So when you come telling me, or somebody comes telling you that his temperature feels higher than yours, you don't have a way of telling whether that is correct or not. There has to be a way of measuring what we are talking about. Now, a physical quantity is any observation, any phenomenon, any concept that is expressed in terms of numbers. Is it clear? Now, in my opening lectures in PHY 101, the mechanics part, I have taken time to deal with this matter. Okay? So a physical quantity is, an observation that is expressed in terms of numbers. What does that tell us? Now, if you asked a child to describe the height of a person or the height of a tall man, he will say, very, very tall, very, very tall. Now, why is seeing the person as being very tall is that because he's looking up to see the person there. The person may not be very tall. Now, relative to a taller person, the person, this man that this boy is describing is actually not a tall person at all. So we have to have a way of expressing this in numbers. Now, to express any observation in numbers, we have to carry out experiments. An experiment is a set of observations, okay, aimed at allowing us to express what we observe in terms of numbers. Now, maybe I will leave you with that in my other video about mechanics part. Will explain this further. So, but how do we quantify? Talking about quantifying our observation. You can only quantify what you observe by, comparing it with another quantity of the same kind. For example, if you are going to measure the length of a yam tuber, let this from my elbow here be the length of a yam tuber. We can use this finger span here, you see, and I can count and say, okay, maybe it is 3. You can see 3 finger span. So this my finger span now becomes the unit of measurement. And the quantity to be measured here is the length of this yam. So we now say the length of this yam tuber is the physical quantity. The word length there is a physical quantity because we can express it in numbers. We can say it is 3 finger span, 4 finger span, and so on and so forth. Now, those of our young men that play corridor football, you are familiar with the measurement of the goalpost. One of the players will use his feet, okay, and measure the goalpost for both sides, isn't it? That is what you've been doing, okay? So the length of his feet is compared with the size of the goalpost. So now, in measurement, you compare the quantity that you want to measure with a fixed quantity of the same kind. That is what it means. Measurement is the act of comparing a quantity with a fixed quantity of the same kind. Right? So in the case of measurement of maybe gari or rice, you notice that we might use what in the local parlance is called the model or a cup. And we say, okay, 3 cups. So maybe 50 cups of gari may be equal to 1 bag of gari, a certain bag of gari. So in other words, the cup there becomes a unit of measurement, okay? And what are we measuring now? We are measuring the quantity of gari that's in terms of the capacity of the bag. You understand it now? So that becomes the quantity that we are measuring. So anything that we cannot express in terms of numbers cannot be called a physical quantity. All right? So that is that. So the last definition that was given, the young man said a physical quantity. Now, so I will accept that in part, a physical quantity that expresses a sensation of hotness and coldness. Well, I will accept that. All right? That's not to say the other definition is not correct, the degree of hotness or coldness of a body. Okay? But then we have to have a way of measuring it. Now, let me summarize the scientific view of the definition of temperature. You will realize later on as we go on that the hotter a material, the faster is the motion of the constituent particles. Now, the constituent particles here, atoms or molecules or whatever that are the constituent particles. Now, in the case of gas, we are going to talk about gas molecules, or in the case of water, we are going to talk about water molecules. Now, those water molecules are in one state of vibration or the other. Okay? Now, but the average velocity increases as the temperature increases. You will understand this better. Now, you know that kinetic energy is dependent on velocity. So if the average velocity of the constituent particles increases as the temperature increases, it means therefore that average kinetic increases as temperature increases. Therefore, we can also define temperature as the measure of the average kinetic energy of the constituent particles of any system. I hope that makes sense. Okay? Now, operationally, you notice that when we are measuring temperature in the laboratory, we use what is called the thermometer. So now we are going to measure temperature in terms of the change in length of a certain substance, isn't it? So we use the property of linear expansion or the volume expansion or whatever to measure the change in temperature. Now, in the case of the thermometer, you notice that what is usually done is that the thermometer is placed in a pure melting ice at ordinary temperature, that's at atmospheric temperature or room temperature if you like, and atmospheric pressure, okay? Say 0 degrees Celsius. That's the melting point of pure ice, okay? Now, and then you take the reading there to be 0 degrees Celsius, for example. And then you now transfer this thermometer and place it in in steam. in steam coming from boiling water, all right, at 100 degrees Celsius. And then you mark the interval, isn't it? You mark the interval. So the difference between this lower fixed point, 0, and the upper fixed point, 100 degrees Celsius there, all right, is divided into what we call the interval. So you have what is called the fundamental interval. The fundamental interval of this length is now the difference between the lower fixed point and the upper fixed point. Is called the fundamental interval. You have heard that, fundamental interval. Perhaps I should write that. Let me write it so that you can see that. Let me spell that. It's called fundamental interval. So I'm going to draw that fundamental interval. So it's going to look like this. So you have, this is my thermometer there. So this is the bulb, okay? And then I have the temperature of pure melting ice here, 0 degrees Celsius. And then I have this 100 degrees Celsius, okay? That's in Celsius degrees. So this difference, 100 minus 0, this interval here, from here to here, is called the fundamental interval, okay? It's called the fundamental interval. This interval from here to here is the fundamental interval, okay? Now, this fundamental interval is divided to a number of equal parts. So in thermometry, use is made of the property of a substance that changes with change in temperature, that increases or decreases with increase or decrease in temperature. You have to take note of that. For example, the change in length, as is the case for the change in the length of the mercury column in the mercury in glass thermometer. So you are familiar with that. Now, I had earlier on appealed to us not to make markings on this. So you are defacing this because I am allowing us to have access to this so that we can see it openly. So you can go ahead and deface it. Everything I'm going to write will also be here. I need to be available for you. Do you understand? Since we are behaving like children, all right. So that is what happens there. All right, so you know about that. Now, let me also go on to some other aspects of it. So then what is the difference between temperature and heat? You see, we have just defined temperature as a measure of the average kinetic energy of the constituent particles. How about heat? How about heat? How do we define heat? How do you define heat? I want to hear your suggestions on that. I will allow you to unmute yourself and speak. How do you define heat?
Can I speak, sir?
Please, sir, I would like to redefine that temperature. I did not get the definition, please.
I said there are two ways. You said we said earlier on that temperature is a measure of degree of hotness or coolness. But I said this kind of definition is relative to whoever is feeling it. We have to have a way of expressing what we are saying in numbers. So now I told us that the definition of temperature that is acceptable, that's the thermodynamic definition of temperature, is based on the fact that the average kinetic energy of the particles that constitute that a system, any system, right, increases as temperature increases. So that can give us an idea of the measure. So we can say that temperature is a measure of the average kinetic energy, right? Or if you like, a measure of the average thermal velocity of the constituent particles of a system. All right. So that is one way. Then we now went ahead to ask us, what do you mean by heat? What is heat?
Okay,
Heat is the amount of temperature.
Now let me ask somebody one by one. Let us have Divine Learner. Please do not speak until I've given you the permission to do that. And unmute yourself so that we have a quiet class.
Okay, sir.
Hello?
Heat
Yes, heat. How do you define heat?
is the amount of temperature in the body.
Heat is not temperature. Heat is not temperature, so I will not accept that. That definition is
Can I answer it, sir?
Hello, sir.
Yes, try it. Yes, you see, let us save time. You cannot say
Okay.
temperature. We want
Okay.
to distinguish.
Heat is the quality.
Heat is a form of energy.
Yeah, but how do you distinguish it from other forms of energy?
Okay, distinguishing it from other form of energy.
Of
is,
course, we have
based on
other
the
forms of energy. Is that correct?
hotness.
Can I talk?
Heat is the condition of quality of being hot.
Eh? Heat is what?
It's the condition or quality of being hot.
No. Please listen. Please listen. Let us try and be
Can I give a
understood.
definition, sir?
Can I give it a try?
Can I give it a try, sir?
Heat is the amount of energy transferred between two given bodies.
Sir, can I try?
Heat is the amount of energy.
All right. Now, okay. All right.
Sir, can I try?
Now, let me ask you by your name. Aloba Taiwo.
It is a form of energy.
Please, the others should keep quiet and mute themselves. And let us have, I will call you by your name so that we have a good, a quiet class. Aloba Taiwo.
Okay, sir. I mean, it is a form of energy that transfers from
Aloba Taiwo. Aloba Taiwo. If I have not asked you, don't speak.
Hello, can you hear me?
Go ahead, I'm listening.
This is an intangible agency that causes increase of hotness in the body.
No noise. No noise.
Let's move on, sir.
Sir, can I have it?
Only that one now. Only that one.
All right. Now, somebody said that heat is a form of energy. All right. It's a form of energy. And I insisted that we have to have a way of distinguishing this energy from other forms of energy. That's what I said. Okay. So, you see, you also know that we have sound energy. We have heat energy. We have water waves. We have radio waves. We have, energy in different forms. That of heat, or heat as a form of energy, can only be defined in terms of its transfer, like somebody suggested, from one object to another from one body to another or from one place to another. So in other words, there has to be flow, okay? But what controls the flow, okay? So that has to be taken into the definition, you see? So if I give this as, a TMA question, you should be able to track it properly. Heat will flow from one place to the other due to the temperature difference between them. That is what I really wanted. A form of energy that is transported from one body to another, transported from one place to another as a result of the temperature difference between those two places or those two bodies, as the case may be. Let me repeat that. Heat is energy transferred from place to place or from body to body as a result of temperature difference or temperature gradient between them. Is it clear now? All right. So now, the unit of energy, the unit of heat is therefore going to be the unit of energy, which is joule. So that's what it means. Okay. So all of that you have inside your course material there. Now, the next thing that I want us to take a look at is this. How do we go about the measurement of these quantities? These things are locked in place. I don't know. Some of you are tampering with them. I don't know. Let me check. It's unfortunate that that's why we are having all sorts of problems.
There is a star above that this screen, a little star by the left-hand side, right-hand side. No, this screen here, this free day trial. Yes, below that your mark, below that your mark.
Well, I don't know. I don't know. Most of you do the things that we ought not to do, and the consequence is that it disturbs the free flow of the class. Okay. I'm quite passionate about this class being beneficial to all because it's a large class. It's a very large class, I must tell you. But you can see that some of the things that I'm trying to share have been the first. So if you like it like that, it turns out to be your course material. It's a good thing that I did not share my own scripts because I have my own scripts of all these impressions. So, but since I needed this space so that I can write as I'm trying to do now, okay, or draw anything. It's unfortunate that most of you are not decorous at all, and I'm disappointed that this is the kind of class that we have at the university level, and most of you are adults and possibly parents. And then if your children do like this, would you like it? We are in a class and you are disturbing the class. You don't want the class to function. All right. So now I'm trying to select the parts of the things in these units that I expect you to take note of. Okay. All right. So like I told you, I was not going to discuss the types of thermometer and all of that. As you can see, all these types of thermometer, the constant gas volume, platinum resistance thermometer, and the thermocouple, and all of that. So I don't want us to, I didn't want us to waste time discussing this because I expect you to be able to read and understand this and be able to answer the questions well. All right. So I was now trying to define what we mean by temperature and show the distinction between temperature and heat. Now, somebody talked about flow of energy, okay? That's of heat energy, or we like thermal energy. Now, when a hot and a cold body are brought in thermal contact, let me write that, thermal contact, thermal contact, thermal contact. All right. Then heat flows from one to the other. Now, if they are in contact, that is, if the two bodies are in such a way that heat can flow from one to the other, they are said to be in thermal contact. I hope that's clear. So when two bodies are in thermal contact, heat flows from the hot body to the cold body until the two bodies reach thermal equilibrium. Thermal equilibrium here implies that until the two bodies have the same temperature. So when two bodies have the same temperature, we say they are in thermal equilibrium. So you have to take note of the terms, equilibrium. Now you can see that I have difficulty writing because I'm using the mouse to do this. This is not a touch screen. So that is what you have to take note of. So, but now, for two bodies to be in contact, it means therefore that there must be no obstacle, or there must be nothing preventing the heat from flowing from one to the other. So now if we have two substances in two different containers that are insulated, okay, then we notice that heat may not flow from one to the other, for instance, okay? If the insulation is good enough, then we expect all the heat to be restricted to the container, of the insulated container. So we talk about this kind of contact through the medium of the contact, or the walls, if you like. So accordingly, you have what we call the adiabatic wall, the diathermic wall, and all of that. So let me now ask us, what do we mean by adiabatic wall from what you have read? Adiabatic wall, or adiabatic contact, or adiabatic
Yes, I can hear me. Can I talk?
Yes.
Can you hear me, sir? Can I talk?
Go ahead and answer that question.
Adiabatic allow transfer of heat.
The word adiabatic means what? If you have read the course material, adiabatic implies what? It means what?
The transfer of
Heat cannot
heat.
pass through
The transfer of heat, sir.
Huh?
The
heat cannot
transfer
pass
of heat.
through
It
The
means
transfer
that
of heat.
it's not transfer of heat. Somebody else was saying.
Adiabatic,
I was saying heat cannot pass through it. It's not it's an insulator.
Okay, an adiabatic wall is one that you cannot have heat transferred through it. Is that what you're saying?
Yes,
No.
Yes, sir.
Yes, sir.
All right. Now let me reconfigure this. Let me stop the share. Give me a minute. Let me reconfigure what I'm doing, so that I will have control over what I'm doing.
So an adiabatic wall is the part of the wall which no heat can be transmitted through.
Yeah. All right. Okay, I will accept most of these views. They can be found in your course material. You can tell what we mean by adiabatic. How about diathermic wall? What do we mean by diathermic wall?
It's a conductor of heat, meaning heat can pass through it.
All right. Yes, I can hear you. You have all of that in your. Can you see all of these are found in your course material here? Diathermic wall. Now let me share that so that you can see where I am talking about, where I'm taking this from. I want you to be able to follow the discussion. Yeah, somebody was talking, so go ahead. The lady. Huh?
I said it's a conductor of heat, meaning heat can pass through it.
Okay. All right. All right. So I will some other opinion on that?
Yes.
Any other opinion?
Yes, I have an opinion on that.
Yes.
Okay, a diathermic wall in this context of thermodynamics is a boundary or barrier that allows for the transfer of heat between two adjacent systems.
Okay. All right. All right. So, okay. So now, if we have an adiabatic wall that prevents it, that restricts it into a particular system, all right? Adiabatic means at constant heat, isn't it? So what I deposit inside remains there, okay? Diathermic means it can be shared. Diathermic, all right, means that we can share the heat from one system to the other. That is, it can be transported from one system to the other. So you have spoken well on all of that. Now, so the next thing that I want us to take a look at is about the principle of measurement of temperature. Okay, that is called one of the laws of thermodynamics. That is called the zeroth law. What does it state? Like the zeroth law. Zeroth law. I want somebody to state that.
Can I talk, sir?
Can you hear me, sir?
No, those I have spoken before. I want others to speak.
Comfort. Can I talk?
Comfort. Let me call the names. Comfort.
Hello, sir. It helps us to quantify.
No, I want you to state it. State it in your own words.
Okay. The zeroth law states that it helps us to quantify the concept of temperature in objects. In my own concept, sir.
That what?
Can you hear me, sir?
Yes, I can hear you. That what?
Okay. I said it helps us to quantify the concept of temperature in an object.
State what the law says.
Okay, what the law says.
Hello, sir.
One person at a time.
Can I talk?
Yes.
With each other.
Go ahead now. Michael Philmon.
Okay, the zeroth law of thermodynamics states that two systems, A and B, are separately in thermal equilibrium with a third system, C, unless the systems A and B are in thermal equilibrium with each other.
No, you didn't state it well. Unless.
Can I talk?
Sorry.
I don't understand that. Now, can you see the diagram that I've drawn? I mean, those things that I've drawn there. Let me summarize what is being said.
Yes, sir.
Now, this is Mr. A, Mr. B, and Mr. C. If Mr. B resembles Mr. A in every aspect, and Mr. C also resembles Mr. A, okay, in every way, then Mr. B and Mr. C resemble each other in every way. Let me repeat what I've said. If Mr. A resembles, Mr. B resembles Mr. A there in every way, and Mr. C also resembles Mr. A in every way, then Mr. B resembles Mr. C in every way. I think this is an analogy that can help us to remember what the law says. So now, to correct that statement that was made by the last speaker there, now if this system, my system B, is in thermal equilibrium with system A, and my system C is also in thermal equilibrium with system A, then B and C are in thermal equilibrium with each other. Does it make sense now?
Yes, sir.
Yeah. So that is all I want us to see.
Sir, please, can you come again, sir? So that is to say that all of them are equilibrium to themselves.
Exactly. That's what we are saying. This is in equilibrium with this, and this. Let me point what I'm saying. If this is in equilibrium with this, and this is in equilibrium with this, then this and this are in equilibrium with each other.
All right.
Okay,
Yes,
sir.
sir.
So that
Yes,
is to say,
it's simply a mathematical axiom. Things which are equal to the same thing are equal to one another. Things which are equal to the same thing are equal to one another. Is it clear? So that is one way of
Okay, sir. In a nutshell, sir, that is both A, B, and C are equilibrium to each other, sir.
Now listen to what the law states.
Okay, sir.
It's actually shown here. You can see if A is in equilibrium with B, and A is also in equilibrium with C, all right?
Yes, sir.
So this what we are saying is if B is in equilibrium with A and C is in equilibrium with A, then B and C are in equilibrium with each other. So in other words, one of them is a reference. So this is a reference object. Please pay attention to what I'm saying. Pay attention to what I'm saying. Pay attention to what I'm saying.
Now.
Hello, sir.
I'm listening.
Please listen to the lecturer first.
I have a question, sir. So
I will
if
give you allow me to paraphrase what I'm saying.
Now.
Then you ask your question. I'll give you the opportunity to ask. Here is
Please
the
let the lecturer finish
and
the
do not
lecture, then
make
you can
mistakes
ask your
about.
question.
Don't make mistakes about what we are saying. Here is the reference body now. The reference body is my A. And I want to compare this and this, isn't it? I want to compare B and C. So I first of all compare B to A, and then I compare C to A. Is it clear now? Now, if B is in equilibrium with A and C is in equilibrium with A, then B and C are in equilibrium with each other. That's what we are saying. So that's what the law says. Is it clear?
Sir. So
this now becomes the reference. So look at it the way it is done here. You have three systems in your own case here. Now this is the reference, isn't it? Now this is a thermal contact, all right? A diathermal contact, while this is an adiabatic contact, meaning that heat cannot flow from here to here, isn't it? That's what you are showing here. Now the whole system is insulated, that is, it is cut off from the surrounding. Okay, so that it does not exchange heat with the outside. So then what we are saying is that this makes contact with C, A makes contact with C through the diathermic wall, B makes contact with C through this diathermic wall also. But they are separated from each other via these adiabatic contacts. Is it clear there? So now this and this will be in thermal equilibrium. If this is in equilibrium with C and this also in equilibrium with C. That's what you will see there. So when you are reading, those are the things to take note of. Is it clear? So that
yes, sir.
So I'm just guiding you to be able to understand this. Okay. Then I have already explained all these other ones as things that you have done in secondary school. All these factors and all that. Let me solve one problem now. I think we will close with that. Let me teach us about how to convert from one temperature scale to another. Conversion from one temperature scale to another temperature scale. Okay, so now let me use a different page. So in this page now, suppose that I have just a minute. I'm trying to draw a straight line there. I'm trying to draw a straight line. I hope I got that right. Yes. I also have another one here. There are several ways of doing it. Okay, so now let this be the Celsius scale. I have issues. Just a minute. I don't know why this is not like this. Give me a minute. Let me charge the laptop before it turns it off. All right. So that's the 0 degrees Celsius of the Celsius scale. So now you have 100 degrees Celsius here. So in between here, you have the fundamental interval, isn't it? So now let us call this X. All right, degrees. We don't know what scale this is, but we want to calibrate it. Okay. Now we can take the temperature here, can be anything at all. Let us say that at this point, this one is about 12 or anything. Let me say 24, for instance. 24x. And here it is about 72x. Okay? Suppose we have a thing like that. Right? So now at the middle here, let's also have this as 30 degrees Celsius. What will be this value here? So we want to calculate this value. Let us call this small x. Okay? Right? So the way to calculate this is this. What you notice is that since this is the ice point, this is the ice point. Ice point. That is the temperature of pure melting ice. Well, let me remove it. Pure melting ice. This is steam. Let us call this steam. Okay.
Peter, can you mute everybody? I can hear you. I cannot hear you, sir. Keeping noise.
All right. My intention was that so that I can call you and ask questions. But since you are not, I will not unmute you again until I finish this class. All right. So my intention is to find this value. Is to find this value now. So I need this value. Okay. So but we know how to do this one. All right. I'm going to give you one to do in my presence, and with that we will close. Okay. After I finish solving this. So I want you to find the temperature. If the question is, if the temperature of a certain temperature scale X, if the temperature of the pure melting ice is 24x, and the temperature of steam, this temperature of steam at normal atmospheric pressure is 72, okay? What will be the reading of this temperature when the room temperature is 30 degrees Celsius? So that is the question there. So to solve this problem is quite easy. All you need to realize is that the fundamental interval, that's from this point to this point, and from this point to this point, is the same for both of them. Of course, this is the temperature of the pure melting ice in this scale, which is 24. And this is the temperature of the pure melting ice in degrees Celsius. This is the temperature of steam at normal atmospheric pressure, okay, in degrees Celsius. And this is the temperature of steam at normal atmospheric pressure in degree X. So we want to find the temperature in degree X when the temperature is 30 degrees Celsius. So how do we go about that? I said we have to realize that these fundamental intervals are equal. So we are going to use the ratio of equal sides. So we can do something like this. You solve this problem like this, you will notice that 100 degrees Celsius minus 0 degrees Celsius, all right, is the same thing as 72 degrees X minus 24. Please let me write this well again, so that you will not make mistakes when you are doing yours. This is degrees Celsius, 100 degrees Celsius. This is C minus 0 degrees Celsius, all right, will then be equal to 72 degrees X minus 24 degrees X. Of course, you know why it should be like that, because we are talking about the same length. The length from here to here is the same length from here to here. All right? Then how about divided by this? If I divide by 30 degrees Celsius minus 0 degrees Celsius will then be equal to, I can also divide this, X, if you like. I should have actually inverted this, minus 24, all right, X degrees Celsius. Well, let me not repeat myself, degrees Celsius, and I will do this written on one side, I mean at once. So degrees Celsius, sorry, X Celsius. I mean, degrees Celsius, this one is X, beg your pardon, I think this is X. This is X. No, I have one. I have one. Take it. Take it. I went and brought another one. Yeah, thank you.
You lock everything.
Yes, I will. But the ones outside can be turned on. I leave this one inside the hall. I will turn this one off. All right. So here is what I was intending to write. Let me correct what I'm writing. This is degrees X. Okay. So this is what I'm trying to write. This is X degrees X. Okay. All over. So I will now have this as this length. This is degrees Celsius. All right. This is 30 minus 0 degrees Celsius. So it becomes clear. I can invert this, can't I? I can invert this. I can invert this. So let me, I could have written it upside down. That means this is the same thing as saying 72 minus 24. So I can write this as so sorry, I think I've written the wrong thing. Give me a minute, let me correct this. This is supposed to be X minus 24. X minus 24. X degrees Celsius. I mean X degree minus that's this X minus 24. 24X. Let me remove this. All right, so let me even remove all these ones and write it once so that it will look neat. Let me write it once so that it will look clean. like this. So it will look like this. 72 minus 24, all right, degrees X. This is degrees Celsius. So let me put everything at once here like that. So that's how it will look like. So that's what you have. Okay. All right. So we can, I said we could have inverted this. So I would have written this at the top and this down, or this at the top and this down. So if I invert, that means I'm going to have X minus 24, X minus 24, all over 72 minus 24 is equal to 30 minus 0, which is 30, all over 100. All right, so I can go down and write this. Let me see. I hope this can go down. The whole thing has gone off. I'm sorry. I wish. What is the meaning of this? So I'm saying that I'm supposed to have X minus 24. If you have written the first part, all over 72 minus 24 is equal to 30 over 100. Now this is going to be in X, while this is in degrees Celsius. All right. Okay, so you can solve this. What we can do here is that, of course, 72 minus 24, this is 12 minus 4 is 8. Okay, so I now have 6 minus 2 is 4. That's 48 down there. Okay, then at the top, I have X minus, you can solve this, can't you? Minus 24. Is going to be 3 over 10 here. Okay, so I can cross multiply and then I'll have X is going to give me 3 over 10 times 48 times 48. All right, okay, then I can transfer this to the other side and add plus 24. All right, in degrees Celsius, I mean degrees X, I beg your pardon. So this is going to give 0.3, all right? If we multiply this, 3 times 8 is 24, so I'm going to have that, 24. 3 times 8 is 24. 3 times this is 12, plus 2 is 14. Then plus 24. Okay, then this is divided by 0. I mean by 10, I beg your pardon. Okay, I hope you have seen this. So this is going to give me, if I shift the decimal point one place to the left, is going to give me 14.4. I'm doing this manually, 14.4 plus 24 degrees X. Okay. All right. So that's going to give us finally it's going to give us what? This 4 plus this 38. 38.4. .4 degrees X.
We can't hear you, sir.
Can you hear me now?
Yes,
we can.
Yes, we can.
Yes, sir.
Now,
Yes,
what
sir.
I have done there is a very simple method. Is it clear to everyone?
Yes, sir, but I want to ask a question.
Just go ahead and ask.
So clear to everyone.
Now, that lady, ask your question first. After that, Osho Andrew. Then those that are using Zoom, and then after that, Leonard. And then let me see the others whose hands are up. The other ones, I don't know their names. Zoom, Edidion. Who else has a hand here?
Hi, sir. My hand's up, sir.
The question should be on what I have just done.
Yes.
Yeah, the lady first. That lady.
I wanted to ask, you did an inversion of the fractions. I wanted to ask, is it a must we must do the inversion? Can't you just solve it straight away?
All right, so here is what I did. So if I'm having this, I could have taken this first, all over this, isn't it? And this, all over this. So it is the way I wrote it in the first part. Now, why did I invert? It is because the x that I'm looking for is supposed to be at the top. That's why I did the inversion. So it is because of the way I wrote the equation up initial. Okay?
Yes, sir.
You understand what I've explained?
Thank you. Yeah, I understand. Thank you.
Yeah. So what I'm saying is that if you have done it, the ratio of this to this, over the ratio of this to this, all right, there would have been no need for inversion. But I did the opposite. I did the ratio of this to this, and equated to the ratio of this to this. So I had to invert in order to bring out the x at the top. It's a question of cross multiplication. Do you understand?
Yes, sir, I understand.
Yes. Next question, 4. Osho Andrew. Osho Andrew, can you hear me?
Yes, I can hear you, sir.
All right, your hands are up. All right, in the absence of any further questions, I think we can close. I think that simple solution.
Sir, before we close, sir.
My hand is up. My hand is up.
Sir, before we close, sir. Hello, sir.
Go ahead, I'm listening.
Okay, sir. What I want you to add something. It's not concerning the class, sir, but it's not concerning today's topic about the class, sir. Please, we need to know the HOC of this class. That's 1. 2. Concerning
that's
the
why you need to ask people inside the group. You need to ask people inside the group.
We need to elect who?
Like class rep and stuff.
Yes. And concerning the assignment yesterday, for those of us that could not send it to your mail, we send it to your WhatsApp, but if not responded.
No, this is a different class now. What are you saying?
This is
a different class.
This is a different class entirely, yo. This is a different class. Yes, I'm coming.
Different class.
This one is the back of class.
You are not going to. Now, let me answer you. Now, you are not going to send any question or answers to me. I'm not marking. If I am giving a solution, a problem that I want you to try out, I will give it on the discussion forum. Is it clear?
Okay, sir. Thank you.
Yes, I will give it at the discussion forum. The idea is for us to discuss. I'm listening.
I wanted to ask, if we are solving maybe on pen or on paper, if we are doing POP, is it a must we draw the diagram for calculation? Is it compulsory?
Our examination is not POP exams. I've drawn the diagrams to illustrate how I got the information that I used.
Okay.
Now, realize that there are 70 questions for you to answer within a space of about 1 hour, 30 minutes, if not less. Now, the questions are made of 2 parts in your e-examination. The first part is MCQ, multiple choice questions. So if they contain calculations, you are supposed to solve those problems and get the calculations right in a split minute, right? A few minutes, I mean a few seconds, or about a minute. And then you choose the correct option. The other part is called fill in the blanks. So the blanks will be given. And then you write in one word or words as the case may be. And then you answer the question. Is it clear? So you are not going to do any POP at your 100 level. Does that answer your question?
Yes, sir. Thank you, sir.
Has everyone joined the WhatsApp group for this class in case we need to pass information?
Yes, sir. That is the most important.
Well,
thing here now.
my phone now I had the screen is a tab. The screen actually turned off, so I'm trying to fix that.
So you can actually
now please listen to me. Please listen to me. I'm the one that you should listen to. The most active platform that is officially recognized by the university is the discussion forum. Bring most of your questions that has any connection with the content of your course through the discussion forum. Is it clear there? That is the most important thing, because the university will be able to see the nature of the discussion that goes on between us. Now, the next thing is that we will also have those that are officially registered, okay, on the discussion forum. So, but if you are adding somebody to any group, that's the WhatsApp group, how will I be able to know whether he is a registered student of this course or not? Is it clear? So you can limit that to yourselves, right? I can only do this. This class is about 1,600 so far registered. I think before the semester ends, we might be talking about 2,000 or 3,000. So I will not know how I will be able to share in such a rowdy communication. But if there is anything that is very, very important as to the timelines, I think you have to appoint a class rep as suggested by one of you, a class representative. So look up amongst yourselves and find out somebody, could be male, could be female, that is responsible, that can take responsibility and communicate on any matter that concerns this course. All right, and then and I'll be able to share with you. I think that way we'll be able to make a headway.
Can I ask a question?
The discussion forum.
I think I want to close. It's already getting dark. The lights have been turned off in my.
Sir, can you just tell us where the discussion forum will be?
The discussion forum is going to be on the first page.
It's on the portal.
Yes. If it is not there, I will create one there. If it is not there, I will create one. And then I will start.
It's under the courses.
Okay, thank you very much, sir.
It will be a block by itself called the discussion forum.
Okay, sir. Okay, sir. Thank you.
Thank you.
When is our next class? So with that, I will try and record another unit, possibly from this or from the other course material, just to be sure that I have fulfilled both ends of this. Okay. So with that, I can say good night to everyone.
Thank you, sir. Thank you, sir.
I want to be sure that you are all benefited from the course.
Bye bye, sir.
When is the next class, sir?
Every week on the same time.
Email, all of you should stop asking.